All right, let's jump right into a really big question for our future on the road. How do we keep our smart cars safe from smart attacks?
I mean, really think about it. Your car isn't just a hunk of metal anymore, is it? It's a powerful computer on wheels, always online, always connected. And all that amazing technology, well, it also opens up the door to some brand new dangers.
You can almost picture it. There's this invisible highway of data constantly flowing in and out of your vehicle. And while most of that traffic is totally fine, some of it can be really dangerous. We're talking about things like zero-day exploits. These are attacks that are so new, so fresh, that no one's even had a chance to build a defense against them yet. This is the new front line for automotive safety. Now, to protect this unseen highway, cars have something called an intrusion detection system, or IDS. The easiest way to think about it is as a digital security guard. It's on duty 24/7, watching every single piece of data, looking for anything that seems out of place. It's our first line of defense.
But here's the catch, and it's a big one. These digital guards, they're only as good as the training they receive. And right now, the way we train them has a massive, fundamental flaw. It's a gap in our defenses, and it's one that attackers are more than happy to drive right through.
So these guards have two basic ways of working. On one side, you've got the signature-based approach. This is like a bouncer at a club with a very specific list of troublemakers. If you're on the list, you're not getting in. Super effective, but totally useless against a brand new threat. On the other side, you have anomaly-based systems. These guys are more like a detective looking for any suspicious behavior. They can spot new threats, which is great, but they can also get it wrong and sound the alarm for no good reason, crying wolf.
And that trade-off leads us to the heart of the problem, what researchers call the reality gap. See, the data we use to train these AI guards is often way too simple, too clean. It just doesn't look like the messy, chaotic data of the real world. It's like training a world-class boxer by only letting them hit a stationary punching bag. What's going to happen the first time they face a real opponent who actually moves and punches back?
So if your training gym is flawed, your fighter is going to be flawed. The solution? You have to build a better gym. And that's exactly what these researchers did. They built a hyper-realistic, next-level simulator for cyber attacks, a place where the AI could get ready for the real deal.
The key to this whole thing, the secret sauce really, is a powerful tool called Scapy. It lets you craft, tweak, and manipulate network data with incredible precision. This is what allowed the researchers to generate a dataset that was, in their words, highly accurate.
And they really went for it. We're not talking about a couple hundred examples here. They created a massive dataset of 100,000 unique network events. That is an enormous library of experiences for an AI to learn from.
So what they built was basically a cyber traffic factory. They could cook up any scenario they wanted. Normal, everyday car communications? Check. A sneaky, malicious attack? Check. Even weird, hard to classify outlier events that might be a totally new kind of threat? Check. It's like a flight simulator for a cybersecurity AI. It gets to experience and fail in a completely safe virtual world before it ever gets put into a real car.
So, with this incredible, rich data set in hand, it was time to get to work. It was time to actually train the digital guard and teach it how to tell the good guys from the bad guys.
So what does the AI actually see? Well, it's not reading lines of code. It's looking for patterns and features like these: where the data is from, what protocol or language it's using, how much data is coming in. And one of the coolest ones is entropy. It's just a fancy word for randomness. It turns out malicious traffic often has a very different texture of randomness than normal traffic, and that's a huge clue for the AI.
Now, the specific AI they chose for the job was a convolutional neural network, or CNN. You've probably run into these before. They're the rock stars of the AI world, famous for being amazing at image recognition. Why? Because they are absolute masters at spotting tiny, subtle patterns in really complex data, and that is the perfect skill for hunting cyber threats. Okay, so the AI has gone through the toughest training program on the planet. It's seen 100,000 different scenarios. Now, it's showtime. Time for the final exam. Let's see how well it really learned its lessons. And trust me, this was no easy test. They threw the kitchen sink at this AI. As you can see from this chart in the study, the test was a messy, complex mix of good traffic, bad traffic, and weird outlier traffic, all using different ways to communicate. It was designed to be just as tough as the real world. So, how did it do?
Well, the first big number is its overall accuracy, an incredible 99.8%. That means for every 10,000 things it looked at, it got over 9,900 of them right. Just wow.
Next up, precision, which came in at 98.96%. This one is so important. It tells you that when the AI did raise a red flag, it was almost always a real problem. In other words, almost no false alarms.
Then we have recall at a staggering 99.11%. This answers maybe the most critical question. Of all the actual attacks they threw at the car, how many did the AI successfully catch? This score means it missed, well, practically nothing.
And finally, we combine those two ideas, not crying wolf and not letting anything slip by, into one number called the F1 score. At 99.03%, it shows the AI found a near-perfect balance. It is the absolute best of both worlds.
This chart just shows it all so clearly. It's called a confusion matrix, but you can just think of it as the AI's report card. That bright diagonal line, that's all the A+, all the correct answers. Everything else, those are the mistakes. And as you can see, it's pretty much a straight A student.
And if you want the ultimate proof, the absolute mic drop moment, it's this. In the world of AI, this is the gold standard. All you need to know is that a score of 1.00 is mathematical perfection. It means the AI's ability to tell good from bad is, for all practical purposes, flawless.
Now, these aren't just incredible numbers on a chart. They represent a genuine breakthrough. So let's talk about what this really means for all of us, for our future on the road.
So here's what it all boils down to. We know for a fact that the reality gap is a huge weak spot in cybersecurity. This research proves that creating high-quality, super-realistic synthetic data is the weapon we need to close that gap. By building these better training grounds, we can finally prepare our AI for the real world. And that is a massive leap forward towards making our cars fundamentally safer. And that just leaves us with one last, really exciting question to think about. This whole method worked brilliantly for cars. But now that we know how to build these perfect virtual training worlds for AI, what other huge, critical security problems out there can we finally go out and solve?